Hello and welcome, I'm your Code Monkey, and here let's learn how to handle camera zoom when using Cinemachine. This is actually pretty simple, but due to how Cinemachine is set up using a certain component system, it can actually be quite a bit tricky to figure out how to change this through code. We're going to see various methods of zooming, in 2D games by modifying the orthographic size, in 3D games by modifying the field of view, or perhaps the best method of all by changing the camera follow offset position to physically move the camera closer. With this zoom and some basic movement, you end up with a very capable camera system. That is actually something I already covered in detail in another video, but I wanted to make this one a separate one since the zoom is really the toughest part to handle through code. If you prefer a more guided path with step-by-step lectures, then check out my complete courses. Learn how to make a Builder Defender game using C#, or learn how to make games entirely using visual scripting. Perhaps if you're past the beginner stage and want to make the jump to advanced, then check out my turn-based strategy course to learn how to manage a more complex project and write some good clean code. Or learn all about Unity with the Ultimate Unity Overview course, which contains over 50 lectures, each covering a different tool or feature of the engine. I'm always available in the Q&A section answering your questions every single day, so check them all out with a link in the description. Alright, so here let's handle zoom with Cinemachine. First of all, if you're not familiar with Cinemachine, check out this video. Basically, Cinemachine is a built-in Unity tool that makes handling cameras super easy. Handling movement, zoom, camera switching, smooth follow, and so on, all of that is made super simple when using Cinemachine. And actually, I've already covered this topic of making a complete camera system in another video. In that one, I made a fully featured camera system with move, rotate, click to drag, edge scrolling, and zoom. But since some people might be specifically looking for this topic, how to handle zoom, this is the more complex part of all the other actions, so I figured I'd make it as a separate video. But if you want a complete camera system, check out the other video. Alright, so over here is my demo scene. For the assets, I'm using the Cinti Sci-Fi pack. This is a great looking sci-fi cyberpunk pack. There's a link in the description if you want to get it yourself. And as a starting point, I've got a working camera here. I'm using Cinemachine, so I have this nice virtual camera. It's set up to follow this other object, which is just an empty object with a system that we're going to see in a bit. So the virtual camera just follows that object. It's got the aim and body as transposer and composer. And over here, it's all pretty standard, just the follow offset, so just so the camera is above and behind the target object. Then on the camera system, I have this script, just handling some camera movements. So over here, just doing some input in order to move it transform position. Another one to handle the method of edge scrolling, and finally another one to handle drag panning. Those are the movement methods, and then finally over here we have the simple rotation, just rotating transform. So with that, here is a camera system working, so I can move around in any direction, I can rotate the camera, and I can use even drag pan and the edge scrolling. Alright, so all of it pretty great. Again, I covered this in detail in that other video. For this video, we really want to focus on how to handle the zoom part. Now, there's actually two ways to zoom a camera. One way is to lower the FOV. So on the virtual camera, here we have the vertical FOV, and if we lower this, then this acts kind of like a zoom. And the other way is over here on the body, we have the follow offset. So if we lower both of these at the same time, then the camera physically moves in closer. So those are the two methods, and both approaches will act kind of like a zoom. And to do all that, we're going to need some player input. Now for zooming, what makes most sense is the mouse scroll wheel, so let's do that. Here in the script, let's set a function to handle our zoom, so handle camera zoom. And then down here, private void for the handle camera zoom. And like I said, we want to use the mouse scroll, so we can access that with input.mousescrollDelta. Now this one is a vector too, because apparently there are some mice that scroll on the X, but for a regular zoom, chances are we just want to scroll on the Y. So let's see what this does. Let's do a debug.log on this one on the Y. So here we've got the console, and if I push the wheel forward, yep, you can see that we have some positive values. And if I pull the wheel back to me, there we go, we have some negative values. Alright, so we've got these values that we can use for our input to handle our zoom. So up here, let's try handling the field of view method first. And now this is why I made this video as a separate video, because this is really the more complex part to making a camera system. And the reason why it's complex is due to how Cinemachine works. So you might think that you can just access the Cinemachine virtual camera. So over here I have a field for the Cinemachine virtual camera. And in the editor over here I've got that reference, and I'm referencing this object, okay? So you might think that you can simply access that and find some kind of field of view, but nope, there's no such thing, no FOV, nothing. So looking at the inspector here, what we want to modify is this field, so we need to figure out how to change this. And thankfully we can easily figure that out because Cinemachine has all of the source code available. So if you just right click on the Cinemachine virtual camera and over here you edit the script, yep, it opens up the entire source code for the virtual camera script. Now if this doesn't open automatically, you can open it manually. So here on the project files, there's a nice little packages at the bottom. And if you expand this, you see all of them. And just in case you don't, then on the top right corner, there's this icon with a little eye. If this one is toggled, then the packages do not appear. But if this one is untoggled, then all the packages are here. So you can go inside packages, inside Cinemachine, go inside runtime, and then inside behaviors. Over here we have the Cinemachine virtual camera. This is where the script is, so you can just double click to open this. And over here, if we do a quick search for field of view, nope, can't find it. Search for FOV, nope, there's nothing here. But if we go back into the editor and we look in the inspector, here we can see that the FOV is inside something called a lens. So on the virtual camera script, if we search for a lens, then yep, now here we do find this. So a field of type lens settings. Now if we try going inside of this type, so here in the project files, let's search for lens settings. And up here on the search bar, make sure you go into all. If you just search in assets, it doesn't show up. If you go into packages or all, it does show up. So let's open this one. And now on this one, if we search for field of view, yep, there you go, it's right here. So this is the method for how you can find any field in order to modify it through code. You can just go step by step through the source code in order to find exactly what you need to modify. There's actually an even more advanced version of this method where you can load all of the package's source code directly into Visual Studio. Doing that makes it super easy to find exactly where the field is that you want to change. And that method works with any packages. In my Ultimate Unity Overview course, one of the lectures is exactly on that topic. How to find any class or any field to modify any of the many tools and features that Unity has. Another example of where this method is required, for example, on the global volume. Post-processing uses this volume component system, and if you just go inside the volume and try to modify, for example, the bloom intensity, you won't be able to do that directly. So that's one of the things that you can learn how to do with that method, which I cover in that lecture. Also, that course teaches you how to use many of the tools and features that Unity has, so check it out with a link in the description. Okay, so back into our demo here, we already figured out where it is our field of view, so we need to go inside the lens to access this. So on the camera system, we've got the Cinemachine virtual camera. From this one, we can access the lens, and then inside the lens, we can change the field of view. So just to test it out, let's change it to something like 10. Then let's do it on input. So let's grab this. So if the scroll delta.y, let's say if we push it forward, so if it's above 0, if so, then let's just swap out the field of view. Okay, let's see if it works. So here we are, and if I push the scroll wheel, yep, there you go, a real nice zoom. All right, awesome. So with this, now all we need is some logic with some proper values. And also we need to handle some smoothing, since right now as soon as we switch, yep, there you go, it changes instantly. We want to be nice and smooth, so let's do that. Over here, first for the valid values, let's first keep track of the current target field of view. So up here, a private float, target field of view. And we can default this to something. So we have this field, and then in here, if we push forward, then let's increase the field of view by some amount. Let's define a float for the field of view increase amount. So if we push forward, we increase it. Let's remove this one, put it down here. And if we push backwards, so if this one is under 0, then let's instead decrease it. Okay, so we have the target field of view, and then at the end we assign it, so we set it. However, like this, we're going to get some messed up values. If we can constantly decrease it, then this is going to go into the negatives. Having a negative field of view is probably not what we want. So let's add some proper minimum and maximum. For that, we can go up here. We can make a serialized field to make it easy to customize. Let's make a float for the field of view min. Let's say the minimum is maybe 5 FOV, and then another one for the max. And let's say put the max at 50. So then down here, we just grab the target field of view, and we can use mathf.clamp. This one clamps a value between a certain minimum and maximum, so we can use the target field of view, clamp between the minimum and the field of view max. Okay, so that makes sure that this one is always within valid values. The last thing we need is really just the smoothing. So we can do that using lerp, which I actually covered in a quick short video. It's a super simple way to make something nice and smooth. In this case, we've got just a float, so we can use mathf.lerp. And we want to interpolate between a start, a final, and using some time. So the start value is going to be the current field of view, so let's use the current one. Then the final one is going to be the target field of view, and finally time will be time.time. And then we need to multiply by a certain zoom speed, so float zoom speed. This works with pretty small values, so maybe just 3f, maybe that's smooth enough, so let's see. So we just multiply time.time by this. Again, if you don't know about lerp, watch that quick video that I made. It's super simple, super easy way to add some nice smoothing. So up here, we set the field of view to this. So we use lerp in order to get it nice and smooth. Okay, so that's really it. Let's see if we can change the field of view in order to make sure it stays within a certain minimum and maximum, and let's see if it's nice and smooth. Okay, so here we are, and if I move, yep, there you go, doing a nice zoom in, and if I move the opposite way, yep, a nice zoom out. All right, awesome. Now here, just in case you have the opposite behavior of what you want, which in this case I do have that, so by pushing the wheel forward, I really want to zoom in instead of out, and by pushing the wheel back to me, I want to zoom out, not in. This is personal preference, up to you which method you want. For me, I want the reverse, so this one is super easy. Just up here, instead of increasing, we decrease, and this one increase. And the zoom was also a bit too slow, so let's put it a bit more. So here it is. Now if I push the wheel forward, yep, there you go, nice zoom, push back, and nice zoom out. All right, awesome. So everything works. I can move the camera, and I can zoom in or out. Okay, great. So here we have our field of view zoom, and it works perfectly. Like I said, this is just one method. For another method would be to leave the field of view, and we just move the camera closer. So let's see that second method, but we want to keep this function just the same. So let's say this is the field of view method. And then let's make another one. So handle camera zoom. And for this other one, let's call it the move forward method. And we're just going to run one of these. So let's make this function. Okay, so here a private void, make this. Now here we're going to leave the field of view alone. We're not going to touch that. Instead, we're going to modify the follow offset. And again, in order to figure out how we do that, we need to use the same method to figure out how we modify it. Here on the Cinemachine virtual camera, once again, we can look and find that the follow offset is inside the body. So let's once again go inside the virtual camera. Let's edit the script. And here, if we search for follow offset, nope, can't find anything. But if you look at this code, you can start to understand how Cinemachine works, and how it works is based on a certain component base. You have a function to get all of the components attached to this Cinemachine object, and you've got another function to get a specific Cinemachine component. Then if you look inside the Cinemachine package, inside runtime, over here you've got a folder with components, and you see all of these. And if you look at these names, and you compare them with the virtual camera, over here on the body, if you see the various types that you have of body, you have third person follow, framing transposer, and so on. And if you look over here, yep, you've got exactly those. Third person follow, composer, then down here the transposer, which is the one that we're using. So each one of these scripts matches up each type that we have here, both here as well as on the aim. So we're using the transposer, so let's open up the Cinemachine transposer script. And over here, if we search, we can indeed find the follow offset field. Okay, so this is the one that we need to change. So back in our camera system, let's do that. Let's go inside the Cinemachine virtual camera. Like we saw, this works with a component system. So let's get the Cinemachine component. And the type that we want is that one, so the Cinemachine transposer. So we have this, and then on this one, we can finally modify the M follow offset. Again, let's do a quick test just to make sure that we have this correct. So let's set the follow offset at 0, 0, just minus 10. So just right behind the camera. And let's do this once again, if input.mouse scroll delta. So when we push it forward, let's do this just for testing. Okay, let's see. So here we are, and if I move the scroll wheel, yep, there you go, nice and zoom. Okay, great, it works perfectly. So we modify the offset. Now again, just like we did, we just need to modify some extra logic, so let's do that. So for changing it, how we want this one to work is by essentially zooming straight in. So we can calculate a vector 3 for the zoom direction, and for that one, since we want to zoom in straight forward, then we can actually use the exact same follow offset. This one is a vector, so in order to get the direction, we can just normalize this vector. Alright, so with that, we got the zoom direction. Now let's just make a field to keep track of the current follow offset. So up here, a private vector 3 for the follow offset. And also we can set this by default, so we can make a private void awake. And on awake, let's get the follow offset, and we just get it from this. So get that one and get the follow offset. So just copy this. Go up here and paste this, so we have the starting follow offset. We can also do the same thing for the target field of view, just in case you want, but default into 50 also works. Okay, so we have the follow offset. Then down here, instead of using all of this, let's use the follow offset. So we've got the zoom direction, then we're going to increase it or decrease it, and at the end we're going to set it. So set it to the final follow offset, so we just need to modify this one. If we push it in, then let's increase this by the zoom direction. And if we push back, so if this one is under 0, then let's do minus equals. Okay, so now we just need to validate this follow offset to stay within valid ranges. We obviously don't want to push too far forward. So doing that is actually pretty simple. We can just check the follow offset. This one is a vector. We can just check the magnitude. So this is essentially the length of this vector. So we just check if this one is under a certain minimum, so we need to define that. So let's go up here to define those. So we float for the follow offset min. Let's say the minimum is perhaps 5 units, and then another one for the max. And let's put also same thing. Doesn't have to be the same, but just same thing, okay. So if this one is under the follow offset min, if so, then the camera is way too close. So let's set the follow offset, use the zoom direction, and multiply it by the minimum. Okay, then the same thing for the maximum. So if the magnitude is above the max, then we set it to the max. Alright, so with that we have the follow offset and it should be working correctly. All that's left is just adding a nice slow smooth zoom, so let's do that. Except over here we're working with a vector3, so instead of mathf.lerp, we use vector3.lerp. So we use that, and again we've got the starting value, so that's this one. Then for the target, that's the follow offset, and time.delta multiplied by a certain zoom speed. So we float for the zoom speed, let's put it at something. So we have this and we set it at this. Alright, so that's it. This is the second method. Let's see if it works. Okay, here we are, and if I scroll, and if there goes zooming straight in, so instead of lowering the FOV, it's actually getting the camera closer, and zooming straight out. Now again, for me, it's also reversed just like it was previously. So up here, instead of plus, do a minus, and over here plus. Also, if you want, you can change over here the zoom amount, so float for the zoom amount. Let's say just so it zooms a tiny bit more. So multiply the zoom direction by this zoom amount, and so on. And yep, now as I push the wheel forward, there you go, the camera moves forward and the camera moves back. Alright, that's great. So we've got two methods working. Now let's actually quickly check out a third method. Instead of zooming in directly onto this position, what we're going to do is just lower the camera closer to the ground. So the logic for doing that is very similar, except instead of moving forward on the follow offset, we're only going to modify the Y. So let's once again make another version of this function. So let's make another handle camera zoom. This one, call it lower Y. Let's make this function. So down here, a private void for this. So for this one, let's actually copy pretty much the exact same code. It's going to be extremely similar. However, we don't have any zoom direction. No, instead we just modify the follow offset.y. So this is the only one that we modify. So just increase it or decrease it. We just play around the Y. Then instead of this type of clamp, we can use the regular one. So mathf.clamp. We're going to want to clamp the follow offset on the Y. So this one between a certain minimum and maximum. So let's go up here to define that. So the follow offset Y min. And again, let's put it pretty much the same values. All of them work pretty much similar. Okay, so we have this. Now down here, use the follow offset Y min and the follow offset Y max. So we clamp the values. And then we're already modifying the follow offset, so then we set it just the same as previously. Alright, so that's it, super simple. Let's see what this method looks like. So here we are, the same camera, same scene. Now if I zoom in, yep, there you go, now it does this kind of zoom. So instead of pushing straight forward, instead of pushing there, it simply lowers the camera. Now personally, I really like this method since it lets you look at objects up close, so it gets the camera right down to the floor, and it also gives you a different perspective. So I think this one is great and works great for many game types, so we can move the camera, rotate, and zoom in just like this. But either way, here you have 3 zoom methods, so choose whichever one you prefer. And finally, let's look at the 2D version. Here I've got another demo. The only difference is the camera is set up in 2D mode, so there's no perspective. And since there's no perspective, that also means we don't have any field of view. Instead, what we have is an orthographic size, and the way we change it is exactly the same as with the field of view. The field that we modify is also inside the lens, so you just go in there and you change, this time, the orthographic size. All the other logic is exactly the same, and that's it, very simple. So here we are, and if I scroll the mouse, and yep, it does work, it zooms in and it zooms out. Alright, awesome! So this is how you can zoom in with Cinemachine using various methods in both 2D and 3D. The tricky part is really just figuring out how to access those fields. If you want to learn that method and many more things in detail, check out my Ultimate Unity Overview course. It's full of lectures teaching you things like this one, like how to find any class or field that wouldn't really work as a runway video. The course covers tons of Unity tools and features, and I'm constantly updating it with free updates. So if you're interested in Unity at all, definitely make sure to check it out. Alright, hope that's useful. Check out these videos to learn some more. Thanks to these awesome Patreon supporters for making these videos possible. Thank you for watching, and I'll see you next time.